Welcome to Mastering Unsupervised Learning with Python. My name is Stefan Jensen, and I've been working with data science for over 15 years in various industries, always applying data science to improve decision-making in business or investment, or also with respect to policy decisions. I have also quite a few years teaching data science to folks on the software development side, as well as to people on the business side, including executives, and using Python for much of my work for over 6 years now. My background is in various quantitative disciplines, master degrees from Harvard University as well as Free University of Berlin, and I'm also a CFA charter holder. So let's take a look at what this course will offer. We focus on three important areas in unsupervised learning, which in itself is a field in machine learning that has been growing in popularity and importance dramatically over the last several years. The first field that we'll be focusing on are advanced clustering algorithms, where we will look at alternatives to the very popular and simple k-means, which solves as a good first step at many problems, but has severe limitations. So we will look at alternatives, which would include hierarchical clustering and density-based clustering, as well as generative models like Gaussian mixture models, all of which have their strengths and weaknesses, and we'll explore how you can make the right choice given the specific situation that you're in and the specific data set that you would like to cluster. Then we'll take a look at topic modeling, which is about finding hidden structure in text data, and this hidden structure takes the form of topics. So the idea is that we are able to summarize text more concisely by identifying these hidden themes that run through documents, and we can use this information using algorithms like latent semantic analysis or latent Dirichlet allocation to summarize text much more concisely than has been done in the past, using sort of the tokens or the words that make up the text, so that we can then recommend interesting articles to users, for instance, based on their profiles and the topics that they have demonstrated interest in the past. The third area that we'll be looking at is manifold learning, which is in autoencoders, which is about nonlinear dimensionality reduction. So it builds on or goes beyond the linear approaches represented by principal component analysis, and you'll see that this enables very powerful visualizations of high-dimensional data in 2 or 3 dimensions, and is also a very useful way to generate new features for supervised algorithms, which often perform better when the dimensionality is somewhat reduced. The goals of this course is to really help you understand the current state-of-the-art methods in various areas of unsupervised learning, and to expand your toolbox so that you can build the skill to actually take a look at this range of different techniques and pick the right one in clustering or topic modeling or dimensionality reduction in whatever situation you are, and then to work on the results of your analysis by visualizing it and diagnosing the results of your work to refine your implementation. In order to succeed, it's important that you are comfortable using Python, because we'll be using a lot of that throughout the course, and of course, it will also help to have prior exposure to supervised and also some unsupervised learning, since this course is intended to be somewhat more advanced and build on some of the mainstays. And of course, it's important that you're curious and interested in data. So I look forward to seeing you in the class.